Okay, welcome back. Had a brief interlude there while I was dealing with some outside background noise that you probably heard, but we'll go ahead and continue on with our problem. We've found the working depth, which is 1/2 inch, the base circle diameter, which is 5.6382 inches, and now we're going to talk about the outside diameter of the gear. So the outside diameter, write this down, is just the diameter of the pitch circle plus, of course, the adds for the addendum. We've already calculated the diameter of the pitch circle. Lucky us, aren't we good? So now all we need to do is add in the values for the addendum, and whoa, boy, we're really lucky. We've also calculated the addendum. So the pitch circle, draw my little circle here, it's very lovely. This is 6 inches. The addendum then is the tooth sticking up through it. There's the addendum. So the outside diameter of this gear is going to be the pitch circle diameter plus the addendum again, because that's added to the overall diameter. So in this case, the OD is equal to 6 inches plus 1/4 inches plus 1/4 inches, or 6.5 inches. Finally, we want to talk a little bit about tooth thickness. This is something that is mentioned in your book, and unfortunately your book does not give you any kind of sample problem as to how tooth thicknesses are calculated, which is a lack in the book, but does, I guess, indicate more that this is a modern book. At one point, say 30, 40 years ago, calculating tooth thicknesses was fairly vital and an important part of any mechanical engineer's repertoire. But nowadays, of course, you tend to get your gear profiles from your CAD package, so tooth thicknesses aren't as big a deal. But I do want to note, and this is fairly important, that the tooth thickness is very easy to get at one point on the tooth, and that is the thickness at the pitch circle. You recall, the circular pitch is equal to the point on one tooth, or the distance from the point on one tooth to the point on the corresponding tooth along the pitch circle. So, nicely enough, the thickness of any involute gear tooth at the pitch circle is equal to the circular pitch divided by 2. So, in that case, for this particular gear, the thickness at the pitch circle is 0.7854 inches divided by 2, or 0.3927 inches. Should we have the opportunity at some point, I may take you through more of the calculations in order to determine the thickness of teeth as you go from the base circle out to the addendum circle. But as I also mentioned, it's not in general a vital calculation for engineers nowadays. That concludes problem 6.10. Hope you had fun with it, and I will see you then on Wednesday in class.